Hello guys, here we will record several videos just to explain the topic of cooling capacity calculation for outdoor telecom cabinet. And it's a long topic, so I will divide it into several videos. First, we need to understand that where does the heat come from inside telecom cabinet. We can understand that most of the load that installed in the outdoor telecom cabinet they will have specific efficiency, right? For example, you cannot make everything 100% efficiency. That means 100% of power will consumed by the devices, which there's a zero heat generated. Actually, it's not. So let's say that, for example, if we have one device, the efficiency is 94%, and then you can expecting that 6% of the power will convert into the heat, which will cause the temperature to increase inside the telecom cabinet. That's why we configure air conditioner for the outdoor telecom cabinet. Now, here, in many cases, probably you cannot find the efficiency this number. So normally, for example, if it is the telecom routers or DWDM devices, you can assume there's one number, very conservative number, for example, 90% or something. Based on that, you calculated the heat generated. Okay. But in my case, it's here is just an example. For example, I have one load that is 4,000 watts, okay, and I have efficiency that is 94%. That means I'm expecting that 60% of the power generated, the heat generated, right? It's like 240 watts. Now, this is not a very precise or scientific, calculation, but it's really enough for us to calculate the cooling capacity configuration in the normal cases. So, I don't suggest you go too complex in this topic, but normally this will work. Then, so let's see that in this cases we have a 4,000 watts. Uh, Multiple 60%, or I mean the 60% is the heat generated, so 240%, 240 watts. Now we have a 300 watts is air conditioner configured as enough. Now when you choose the air conditioner specification table will tell you some numbers like you see this is a typical air conditioner specification table. Then we can see that the cooling capacity at L35 is 300 watts. Now that means it can transmit the 300 watts, exchange the 300 watts heat from inside the telecom cabinet into go to the outside of the telecom cabinet. Okay, so this is the concept. Okay, now there's a L35 later. I'll explain. This is another very important topic. Okay, then you see that normally we will how to say we will we see the specification table. Normally the air conditioner provider will give you another table, which this is the equivalent cooling capacity curve. Okay, then how to read it? I mean, for example, cooling capacity is 300 watts at L35. That means inside the cabinet, your target temperature is 35. Okay. Now, for example, this is the target temperature inside your cabinet. Okay, and this is the external environment temperature. So this 300 watts cooling capacity, I assume that the outside of the cabinet, the environment is 35, and inside the cabinet, the target temperature is 35. I can reach 300 watts cooling capacity. Okay, obviously, if outdoor environment change, it will change, and this causes another problem. Okay, later we will explain. Okay, so you can see if we understand this table. So let's see that previous case we have this case, right? We have a 4,000 watts load and the efficiency is 94% and heat generation 240. Now this seems to work, right? AC cooling capacity is 300 watts. Now if we give assumption that outdoor environment is 35, inside target temperature is 35, it will work. But things is not that ideal, okay? Uh, so this is the case. Okay, I mean right now, for example, if I have a 35. Sorry, here's some mistake. If I have a 35 target temperature and 35 environment temperature, it can reach 300 watts, right? Now you can understand if this is 35, sorry, it's 25, 25. For example, if we go to 25 degree, 25 degree, we find a, for example, inside the telecom cabinet, we have 25 degree centigrade target temperature. We find this curve, right? And if we have a 25 environment here, now it will same reach 300 watts, right? So that you can understand. But as I explained, it's not that ideal, okay? For example, if we have an environment that is 40 degrees centigrade and the target temperature is 25, now we find that our target temperature is 25, we use this curve, right? I mean, using Ti equal to 25 degrees centigrade. And the environment is 40, so we can see that we find the point here, right? Now here is 225, here's 150, so it's around 200, right? Now we go back to our cases. Here we have a load of 4,000 watts, efficiency 94%, and we have a heat generation is 240, right? Now, and we can find it here if it's 40 degrees centigrade in the environment, the cooling the cooling capacity, let's say equivalent cooling capacity for the air conditioner is only 200 watts. Now, so that cause the cooling capacity is smaller than heat generation. That will cause problem. Well, that is it is a key problem that happened in some of the carrier customers that we know. Here, let's give you one more detailed example. Here, for example, this is one example in Colombia. Okay. Now we can see that in Colombia, the temperature in summer is different. Okay. For example, site one and site two. Site two is kind of 2015 something. It's very cool because it's in the mountain area. In the north beach area, there's like a 35, 40 or something, right? Okay, geographically, different region has different temperature. So this is one thing. Second is we need to understand that, for example, in the winter, I mean, Colombia probably there's no winter, but actually in winter it's a little bit cooler. Okay, in summer is much more it's hotter, and then we can see that because the environment temperature will be changed, right? First, based on geographical location. Second is based on the season, right? But we can understand that normally most of the telecom devices provider, they will give you a configuration based on what my load here it is, and calculate the heat, and I configure the air conditioner. But they never consider that this issue, the environment temperature difference between different regions. Because you need to understand, for example, if there's one DWDM project or there's one core order project, they will design the whole backbone network, for example, 20 sites, 30 sites, or something. And everything is based on one same configuration, right? I mean, for example, I have, I mean, the, the, the same baseline, like I have a 3,000 watts load, 4,000 watts load. I can figure how what kind of air conditioner based on the cooling capacity. For example, this table cooling capacity is how much and the load how much, right? But normally people will not consider the environment temperature difference between different regions and the environment temperature difference between different seasons. Okay, so that causes a serious problem because, as I explained here, that will happen because at the beginning they consider is 35 degrees inside tech cabinet, 35 environment, or let's say 25, 25, whatever. So this is their baseline to consider, right? And they configure 30 sites, 40 sites. Then later, you go to summer. Some of the site, the outdoor environment is 40. Some is normal. So that causes problem. All right. So this is a very important concept that we need to understand to configure the cooling capacity for the outdoor telecom cabinet.